Okay, here is week 6 for Algebra, starting a new chapter. Monday, Tuesday, Wednesday, Thursday are lessons, one worksheet, and then quiz on Friday. Again, there's my email if you have any questions. So let's get started. So we're starting 11.1, which is parallel and perpendicular lines. The symbol for parallel are two lines that look like an 11. The sign for perpendicular is an upside down capital T. All right, first, let's review y equals mx plus b. M is the slope, which is going to be important in this lesson. B is the y-intercept. Won't be using that too much today. All right, so directions, find the slope. So the slope is the number in front of x or in front of the parentheses. So in this case, the slope would be right there, because the other formula is the point slope formula. And again, it's the number in front of x or the number in front of the parentheses. So in this case, the slope is 0.6. Now the second one's a little harder. We got to do a little work there. Say it's the number in front of x, but you have to get the y by itself. So in this problem, you can see the y is not isolated. So we need to isolate the y, so I need to get rid of the 4x, and I need to get rid of the negative 3. So we're going to subtract 4x from both sides. Cancel. Bring down the negative 3y. You can't subtract x's from numbers, so if you notice I wrote it off to the side. And then I'm going to divide by negative 3. Now all I'm concerned about is the number in front of x. So I could, divide by negative 3. So I can distribute or divide both terms by negative 3. So I could break this up into 10 divided by negative 3 and negative 4x divided by negative 3. Again, all I'm concerned about is the slope, which is the number in front of x, which would be right there. Two negatives make a positive, so that's positive 4 over 3. All right, let's get some definitions down. Parallel lines have the same slope. So for example, y equals 3x minus 4 and y equals 3x plus 2. They both have a slope of 3, therefore they are parallel lines. Perpendicular lines, two ways to remember this. Again, the symbol for that is an upside down capital T. They have a product which equals negative 1. Now remember, product is the answer to a multiplication problem. Another way of looking or remembering it is the slopes are opposite reciprocals. So for example, y equals 2/3 x plus 4 and y equals negative 3/2 x plus 2. The slope of the first one is 2/3. It's the number in front of x. The slope of the second one is negative 3/2. If we look at 2/3 and negative 3/2, those are opposite reciprocals. Opposite means to flip the sign, positive to negative. Reciprocal means to flip the fraction. The bottom goes to the top goes to the bottom. So 2/3, negative 3/2, those are opposite reciprocals, therefore they are perpendicular lines. Now where it's a little harder is in a problem like this. Y equals, if they make it a decimal, 2.5 x minus 3, and y equals negative 0.4 x plus 2. The slope again is the number in front of x, so this one is 2.5 and this one is negative 0.4. Now we should be able to tell immediately that they're not parallel. Those are not the same numbers. But this opposite reciprocal doesn't really help me when they're decimals. So the other definition is good to look at too. Have a product of negative 1. So if I multiply these, if that equals negative 1, they are perpendicular. So I check it, 2.5 times negative 0.4, and we will find that that does equal negative 1. So therefore, these two slopes are perpendicular. Find equation in point slope form. Again, point slope. It doesn't matter, like up here I put the y1 in the back. I'm just going to put it in the front. It does not matter if it's in the front or the back, but that's where I'm going to put it. So we want to write it in this form. Looks like we just have one example. Passes through 4 comma negative 1 and is perpendicular to y equals 2x minus 6. All right, so the 4 is our x sub 1 and our negative 1 is our y sub 1. We know when we write an equation there's going to be a y. I'm just going to write the formula down again. But when we write an equation, we know there's a y equals x. So nice and lined up. It's going to be parentheses. So our x sub 1 is 4. Now remember, it's x minus that number, so x minus 4. Kind of do the switch of the signs. The y sub 1 is negative 1, so I'll just put that there. Now the only thing I need to find is this slope. So I look at this. The slope of this equation, again, is the number in front of x. So the slope is 2. Now they want the line that's perpendicular to that. So again, if we remember, perpendicular are opposite reciprocals. So I need to find the slope that's perpendicular to 2. Might not be a bad idea to make this a fraction, so any number can be written over 1. So to take the opposite, we switch the sign. This positive becomes a negative, and the reciprocal means to flip the fraction, 1 over 2. So the slope that's perpendicular to this equation is negative 1 over 2, and that's the slope that we're going to use for this problem. So we can put plus a negative 1 over 2, or we could change that to a minus 1/2. Finally, in this section, we have some definitions. These are words you probably all heard of, but you might not know exactly what they mean. Quadrilateral. Quadrilateral is a four-sided figure. Examples could be any of these. Those are all quadrilaterals. Four-sided figure. a parallelogram is a quadrilateral, just going to abbreviate quadrilateral, with opposite sides parallel. Now there are more thorough definitions than this, but we just want the basic definitions. How I show that opposite sides are parallel are with arrows going in the same direction. So none of these, even though they might look like they're parallel lines, we cannot assume it unless we see the symbols. So none of these are parallelograms because they don't have symbols on it. But if I put, so right now that's not a parallelogram, but if I put an arrow going the same direction on both sets of opposite sides. So this is saying the top and the bottom are parallel, and then now this is saying that the left and right are parallel. So now that's a parallelogram. Again, these are not because they do not have any symbols on. You have to have the symbols to show that it's opposite sides parallel. A rectangle is a parallelogram, again I'm going to abbreviate, with 4 congruent angles, or 4 right angles. Again, this might look like a rectangle, but it isn't until I put in the symbol for right angles. A right angle is a 90-degree angle, and the symbol we use for that is a box. So now it's a rectangle. So if I ask, going back up here, if I ask what's the most descriptive name for this, we would not say that's a rectangle. It looks like one, but it needs the symbols to be one. This is a rectangle. And it doesn't matter how you draw it. I can make something that looks like a square. All right, that looks like a square, but that's a rectangle because it has the 4 boxes in it. One you might not be as familiar with is a rhombus. A lot of people think of rhombuses or rhombi as being a slanted figure. They can be, but they don't have to be. It's a parallelogram with 4 congruent sides. So rectangle is 4 congruent angles, rhombus is 4 congruent sides. So I don't have to make this slanted, but how I show it, to be honest, doesn't matter how I draw it, but usually when I draw something, I make them all look like squares. Again, right now, this is just a quadrilateral because it doesn't have any symbols. To show that the sides are congruent, we use what are called tick marks. That's a rhombus. If we put a rhombus and rectangle together, we have what is called a square. That's a parallelogram with 4 congruent angles and sides. So it is both a rectangle and a rhombus. So this is a little misconception that people don't realize. All squares are rectangles, but not all rectangles are squares. All right, so to draw a square, again, that's not good enough. Right now, all this is a quadrilateral because there's no symbols on it. So I have to put 4 congruent angles and 4 congruent sides. So right now, it's still not a square. This is a rectangle. But once I put the tick marks in here too, now it's a square. Last 2 definitions, we have a trapezoid. That's a quadrilateral with 1 set of opposite sides parallel. So a parallelogram has like 2 opposite sides parallel. A trapezoid is a quadrilateral with 1 set of opposite sides parallel. A lot of times people draw this figure when they draw a trapezoid, but it doesn't have to be slanted like that. I could draw something that looks like a square, but to show that it's a trapezoid, I need one set of parallel lines. Again, how you do parallel lines are the arrows. So it doesn't matter if I put it on the top and bottom or the left and right, but just don't put them in both spots or else you have a parallelogram. So that is a trapezoid because it has one set of parallel sides. And the last definition for this day, or this lesson, is a right trapezoid. And that's just a trapezoid with right angles. So again, we have a trapezoid. To make it a trapezoid, we put the arrows in here. To make it a right trapezoid, we put boxes on one of the sides that intersect the parallel with the non-parallel side. So you don't put it over here either. You don't do that. It's just on one side. Usually when people draw, this is good, but usually how people draw a right trapezoid is like this. That gives you a better visual. One side has right angles, but the other side does not. All right, and that's the first lesson. We're actually spending kind of like 2 days or 2 lessons on the first section. So this is actually 11.1b. Deductive and inductive reasoning. Before we do that, we're actually going to take the last thing we did just before a step further. Write the most descriptive name between a parallelogram, quadrilateral, and rectangle. So these are your only choices. To do stuff like a square, you might need to have a distance formula, which we'll learn, I think, actually next week. So the answer is one of these 3. All right, 4 points form quadrilateral. All right, so here are 4 points that form a quadrilateral. I think it's a good idea to actually draw it out to get a better visual. You don't have to, but to me it's maybe a little hard to do without this. Now I don't have to put in all my tick marks and everything. I just need a rough estimate where things are located. All right, so -9, 1 is 9 spots this way and 1 spot up here. And let me just label these A, B, C, and D. I think that's going to be helpful too, and you'll see why in a little bit. The next one is 3, 9. That would be a little to the right and up a lot more. 9, 1 would be over here somewhere. And -3, -7 would be down here. So now I at least can visualize this picture. Now again, we can't assume this might look like a rectangle or a trapezoid or something. We have to do some work to figure it out. But at least I know now which letters are next to which. So I think this is good to do. All right, now how you find out what type of figure it is. We know for sure it's a quadrilateral, but we want the most descriptive name. So to see if it's a parallelogram, we have to check the slopes to see if they are opposite reciprocals. So we basically need to find the slope of all of them. AB, So we'll start, it doesn't matter which one you start with, let's just do AB. Now if you remember, formula for slope is the change in y over change of x. So we're going to subtract a and b. So the y's, doesn't matter which way you do it as long as you're consistent. I'm going to go this way. So 9 minus 1. And then I have to go the same way with the x. 3 minus negative 9. 9 minus 1 is 8. 3 minus negative 9, that becomes 12. It's probably a good idea to reduce that down. That becomes 2/3. Now I'm going to check the opposite side. Again, it doesn't matter what the order is, but you got to do them all anyways. But I want to quickly find out is if this is parallel. For these two lines to be parallel, these two have to have the same slope. So I'm going to do DC next. All right, DC is right here. So again, we subtract the y's. I'm going to go big minus small. 1 minus negative 7. Have to go the same way with the x's. 9 minus negative 3. That's 8 over 12 again, which is 2/3. So what that tells me is these are parallel because they're the same. So right now I have a trapezoid, even though that's not one of my answers. So I got to check the other two, AD and BC. Again, it doesn't matter what order you're doing them in, you got to do them all anyways. A and D, those are way away from each other. Subtract the y's. Again, I'll go 1 minus negative 7. Subtract the x's. Negative 9 minus negative 3. Again, we can use a calculator if we need to. That would be 8 over negative 6, which reduces down to negative 4/3. And hopefully that makes sense. These lines are going down, so they better have negative slopes. Let's check BC, see if we get the same number, because then that would mean those two sides are parallel. BC is right here. Okay, we'll subtract the y's, 9 minus 1. Have to go the same direction with the x's, 3 minus 9. That's 8 over negative 6, which again is negative 4/3. These two are the same, so that makes these parallel. So now I know for sure I have at least a parallelogram. The last thing I check for is a rectangle. A rectangle has perpendicular sides. So for these to be perpendicular, they have to be opposite reciprocals. 2/3 and negative 4/3 are opposite, but they are not reciprocal, so they are not perpendicular. And if they are not perpendicular, they are not rectangles. So this problem is a parallelogram. Opposite sides parallel, but not right angles. Let's try another one. Negative 2, 5, 1, 5, negative 2, 1, and 1, 1. Again, I would label them A, B, C, D. You don't have to, but it makes it easier to label. I would sketch these out. Negative 2, 5 over here. 1, 5 around here somewhere. Negative 2, 1 over here. And 1, 1 over here somewhere. So it might look like something, but again, we can't assume that it is something until we find these slopes. Again, it doesn't matter the order, whatever. I'll do AB first. 5 minus 5 is 0. 1 minus negative 2 is 3, so that slope is 0. I'll check the opposite side next, because I want to figure out fairly quickly whether these are parallel. See if they have the same slope. 1 minus 1 is 0. 1 minus negative 2 is 3. So sure enough, they both have a slope of 0, therefore they are parallel. Let's do the other two. AC, 5 minus 1 is 4. And then negative 2 minus negative 2 is 0. This is actually undefined. Okay, let's check. So there's no slope. Check BD. 5 minus 1 is 4. 1 minus 1 is 0. Again, that's undefined. So since they're both the same slope, they are parallel. So again, we have at least a parallelogram, but now we want to check for right angles, opposite reciprocals. So this can be a little tricky. It doesn't look like they're opposite reciprocals, but 0 and undefined actually are opposite reciprocals. Basically, you have 0 over a number, and you have a number over 0, and it doesn't matter if you put a negative on one. Those are opposite reciprocals. So 0 slope and no slope are always perpendicular. So these are right angles. Therefore, this is a rectangle. All right, let's go to some definitions. Not example, but definitions. Deductive reasoning states that showing that statements follow logically from assumptions or facts using definitions and or properties. So basically it follows a systematic order where one thing leads to the next. And we'll give examples in a little bit. Inductive reasoning is making conjectures, and conjectures is just a fancy term for guess, based on examples or data. So one is more of a proof, deductive, where one is more of a guess, inductive. So we'll do, excuse me, we'll do 3 examples. Tell me whether it's deductive or inductive reasoning. All right, first example. We have 3 to the 4th times 3 to the 2nd equals 3 to the 6th. X to the 3rd times x to the 6th is x to the 9th. Therefore, this is the symbol for therefore. Therefore, b to the m times b to the n equals b to the m plus n. Now it doesn't matter whether we know if this is true or not. Some of these may not even be true. We just need to know if this is inductive or deductive reasoning. This actually is a rule that we learned a long time ago. Hopefully you remember when the base is the same in a multiplication problem, we add the exponents, keep the base the same. But again, we don't really need to know that in this section. We just need to know, is this an example of inductive or deductive reasoning? So again, deductive reasoning is a step-by-step process that one step follows the next, where inductive is guesses based on a bunch of examples. Now, if you look at these are a bunch of examples. We did not get this from this. So this is not, this became this. This is an example. This is an example. So we're going to make a guess that, okay, in the first example they added, in the second example they added, so we'll just say we can add all the time. So these are just examples that lead to a guess. So this is an example of inductive reasoning. And this is a true statement, not that it matters, but it is a true statement. All right, let's do another example. 3x plus 4 equals 19. 3x equals 15. X equals 5. Now they didn't show any work, but this is an algebraic equation. So it looks like they subtracted 4 from both sides to get 15. Looks like they divided by 3 on both sides to get 5. This is a systematical problem where one step leads to the next. How did we get to this? We subtracted 4 from both sides. How did we get to this? We divided by 3 to both sides. So this is a step-by-step process to get to an answer. It's not a bunch of examples where we're making a guess. This is a systematical step or process where we get to a solution. So this is an example of deductive reasoning. So again, inductive, bunch of examples, take a guess. Deductive, do a couple steps, get to an answer. It's like baking a cake. You do a bunch of steps, you get to the cake. Let's try one more example. 1 times 2 is an even number. 2 times 2 is an even number. Therefore, and I could put the therefore here too, so just by seeing therefore doesn't mean anything. Therefore, 2 times any number is an even number. So again, we don't need to figure out whether it's true or not, and to be honest, it's not true. 2 times 0 is not an even number. Or 2 times 1/2 is 1, that's an odd number. So, but it doesn't matter whether it's true or not. We just need to know what kind of reasoning are we using.